In this video, we will look at two more problems which are related to recursive solution, and those of these questions are actually related to array. So let's look at the first problem. So we want to write a recursive function to sum up all the elements in an array of integer. So if we want to come up with an iterative solution, it should be very straightforward. We just need a loop to iterate through each element in this array, and then we can add up all those array elements and return the result. That should be very straightforward. But as we said in our previous video, for all those problems that we see in this module, we could have an iterative solution and a very concise iterative solution. But we want to use those problems to practice and to develop our recursive thinking skill. So how we can come up with a recursive solution for this problem? Let's first define our recursive function. Just like what we said, we need to have a definition of our recursive function. So for this recursive function, what we would like to do, what's the definition of it? It should be like we want to sum up all the elements in an array of size n. So if this is the definition, then how we could translate it into Java code. So we can say public static, and I know the sum of all those elements should be of type integer. So we just return integer, and let's just give a name for this recursive function. Let's say sumElements. And I know for the input should be an array. Okay, so we just pass in an array, and the size of it or the length of it is n. So later we will keep updating n. We will each time we will look at the smaller sub-problems. That's to say, we will look at a subarray by decrementing n by 1 each time. So eventually we will reach the base case. So that's the general idea. So now let's just ask one more question. What we should do if we want to come up with our recursive solution, what are two most important components or two parts whenever we want to construct a recursive solution. So hopefully you remember that the first part should be the base case, and the second part should be the recurrence relation. So what should the base case is? So for this example, we don't need to have a precondition saying that we have at least one element in this array, because now, as long as this array, if it's an empty array, then we just return 0 to say that the sum of all the elements in the array is 0. If the element, if the length of the array is 1, then we will just return the element at index 0. So the base case should be very straightforward. If we have an empty array, that's to say if n is equal to 0, we just return 0 as the sum result. Okay, so that should be straightforward. If n is equal to 0, return 0. So what about the recurrence relation? As we said, let's say we use the same array here. So the input of this function is 4, 12, 11, 92, 31, and 2. And the output, I didn't calculate it, but I know it should be add up all those elements. So that should be the output of the sum of these array elements. Okay, so how I can decompose this original problem into subtasks. So we know for the first subtask, maybe we could just like our previous example, smallest element, maybe I could just look at the sum of the array of length n minus 1. Okay, so we just look at the first 6 elements in this array and get the sum of all the elements inside of this subarray. Okay, so that's to say, if I call this sum elements on this array of length n minus 1, that's to say I just look at the first 6 elements inside of our original array. That's to say for this one, the input will be leaving out the last element, and we will get the output, which should be 4 plus 12 plus 11 plus 92 plus 30 plus 1. So that should be the result that I will get, because I know this recursive function will give me back this output when I have this input. Okay, so now this is the first subtask that we have to work on, and with the second subtask. The second subtask is we have already dealt with the first 6 elements. We still have the last element that we haven't tackled yet. So what we want to do here is we want to get the last elements. Okay, so we have the last element, which is array n minus 1. So the index of the last element is always 1 less than the length of the array. So we get this array element, the last element at index of n minus 1. So we get these 2 subtasks, and how we can produce the result for the original problem by combining these 2 subtasks. So we could say that if I know the sum of the first 6 elements, if we just add this result, okay, with the last element value, then I just get the sum of all the elements in our original array with 7 elements, right? So we just want to get the result of A plus the result of B, and that's exactly what we want to return for our original problem. Okay, so I think the idea should be very straightforward now, so let's just implement it in Java program. So what we want to do here is we want to first get the sum of the first 6 elements. Okay, minus 1 elements, 6 elements, the first 6 elements, which is 4, 12, 11, 92, 30, and 1. Okay, using this recursive function, because based on the definition, when we have the input for 12, 11, 92, 30, and 1 here, okay, based on this definition, if we have the input, then we could have the results, which is the sum of all those 6 elements. So we could just pass in this array with length of n minus 1, get the first n minus 1 elements sum, and then sum up with the last elements here. Okay, so and we can return the final result, and that's how we can come up with our recurrence relation. So if we just call this method sum elements array dot length, we could get the result, which should be the sum of all the elements in this array. Okay, so that's how we can come up with our recursive solution for this question, sum elements. And actually, we won't cover how we can convert this to be a tail recursive function, because I would like to leave it to you to come up with that recursive tail recursive function. It should be very straightforward, but I hope you could practice more on how you can have a more efficient recursive function by converting this pure recursive function to the tail recursive function.